Okay, we have some time to make up, so we should make a start. My name is Chris Abbott. I'm chairing the next two sessions. So we have two speakers before coffee. We've been asked to finish by 15:15, so the speakers will still get their 20 minutes, but obviously we'll ask you to be as precise as possible in the question part, so that we get a short coffee break at least. So our first speaker is Adam Gavin, and I won't read out his title because it's on the screen for you anyway. Over to you.
Hello, my name's Adam, and my project, which I submitted my conference paper for, was a part of my MSc at Nottingham University. It was a collaboration between NTU and PepsiCo Walkers, and I created a simulation utilising modern virtual reality technologies to promote lean thinking in the workplace. It was also to demonstrate the man-machine interaction, and I did this using Oculus Rift and Z-Space, which are two different VR pieces of hardware. I used the scripting of the project was mainly C# and JavaScript and Unity 3D. So yes, lean methodology. PepsiCo, in their workplace, they adhere to a methodology called lean, and this is basically anything other than the creation of value for the customer is seen to be wasteful and sought to be reduced upon and ultimately eliminated. And it's a manufacturing methodology which stems from post-World War II Japan, and it's the elimination of muda, which is known as waste, something that creates no value. And this obviously led to the success of becoming one of the world's largest car manufacturers today. And the breakdown of what these lean wastes are, I'll go through them. There's transport, which is transport of goods to retail outlets or around the plant. Inventory, so we'll build up of materials. If you've got things built up in a plant or a warehouse, then and it's not being sold or moved, then it's wasteful because it's just empty space being used. And then motion is the amount of actions taken to complete a task. Waiting, which is if you're waiting for a machine to produce something and you can spend that time doing something else, again, that's wasteful. And it's all about reducing these sorts of wastes. Over-processing, just going into more detail than necessarily needed. Overproduction, which is making more than necessarily needed, and finding defects, which is all quite self-explanatory. So in the workplace, they're always trying to reduce upon these. So having a simulation that can teach the workforce what sort of problems can arise in the manufacturing cell is quite important. From my research, my primary research, I gathered that different levels of employees all have different perceptions of what lean was. So working out, so having a simulation that gets everyone to a certain standard and standardising the information presented to them through virtual reality is an effective form of doing that. So yes, as I said before, it was written in C# and JavaScript for Unity 3D, and the two simulations that I designed and created, the learning simulation, we're using the Oculus Rift Development Kit 2, it was a first-person simulation. You could walk around the new proposed manufacturing cell, you could interact with the machine user interface, you could fly around it, you could hover around it, and then there's the design simulation, which was using the Z-Space, as you can see in below, as an example of what it looks like, and you put on the glasses, and it's got four little receptors in the corner of the glasses, and you can basically look at 3D models in perspective, and it's actually very cool as a design element, especially in terms of CAD. So what this allows for is a breakdown of what virtual reality can do for a learning program. I broke it down into design and learning. Again, it's the design tool itself was quite basic. It didn't go into like a numerical detail as you would see in most CAD programs, but it allowed the user to drag and drop machinery around, as I'll show you in a moment. The learning simulation incorporates the GUI, fly controller, Xbox control support, as well as keyboard, because some people aren't very good at controlling keyboards, carry some keyboards. Most gamers are and things like that, but Xboxes are more universal. So yeah, the design simulation allows you to assemble manufacturing cells and create work travel paths. And you can use a spline tool that's quite cool. So the game-based learning. This is so what I took from my research through game design to create a manufacturing simulation software was visual affordance with semiotics. This certainly helped out in the user interface that I redesigned for them. Having colours and iconography to break down information for them, rather than just having to read information, they can look at colours and they can pick up things a lot quicker. For example, this is StarCraft 2 there. The different colours, so you can kind of tell from that big bar that that character is a boss. and the smaller green bars are infantry units. So you can just like size, colours and things like that can break down information without having to actually read the fact that that's how much life they've got and that's the character. And then obviously with virtual reality you've got a higher level of immersion than you would with desktop virtual reality, which is just looking at a desktop screen. So if you put on the Oculus Rift, you can get a high sense of narrative immersion, which would be level design, characters, gameplay elements, and then you've got your strategic immersion, which is more along the lines of something like chess, where you're very focused on the game and it's all about making the right move. And then you've finally got tactical immersion, which is normally reserved for first-person shooter players. There's not really a lot of cognitive function there. It's more very instinctual. Everything happens very instantly. So while tactical immersion wasn't really present in my simulation, narrative was, because it was always about the level design, and taking it further, you could even implement a multiplayer system, which is intended eventually, where you can interact with characters who are maybe other actual real players or artificially intelligent characters who can basically be the workforce characters who can go around the planet and you can interact with them as well as issue commands and things like that. And structural scaffolds. Now, this is something that I want to implement into the simulation at some point. A good example of this is in tutorial levels of games. In structural scaffolds, it will give you an example of how to do an action, how to run, jump, or attack, and then you can play a video of doing that, and then you have to emulate that after, and that's like a good way of directing you how to perform certain actions, and that can be transferred to running certain tasks in a plant, where you can change, you can fix pieces of machinery, it can show you how to do it before it's actually been done, and you can give you the tools to do it yourself. And then control accessibility, that's more or less what I was saying about the Xbox controller support, giving people a variation of how they can access the technology rather than just giving them one thing and they have to learn it. If they're familiar with something else, then give them that sort of control. Yes, this is the first person part of the simulation. It's going to use an Oculus Rift. You can walk around the simulation, you can interact with the machinery, you can go up with these industrial PCs, you press E on the keyboard or X on the controller to interact, and you can access the on-screen user interface. You can actually click on all the buttons and stuff like that. I used an add-on called OnGUI through Unity. I don't know if any of you are aware of that. It's actually quite a good piece of kit. And it's basically a mock GUI. You can go around all the buttons and stuff like that, but it obviously doesn't have any impact on the actual machinery because it's only a 3-month project, you see, so animating everything would have taken years. See, this is the Z-Space screen, and this doesn't really do it much justice because it's actually a projected 3D image when you put the glasses on, and when you look around it, it'll always show it in perspective, which is actually quite cool. All the different functions on here are basically open source. I used pieces of their code and chopped it and just basically put it into my simulation to make it work within this project. It's actually very good because you can actually import other 3D files, so you can actually import new pieces of machinery into the scene without actually having to load a new game each time. You can change the backgrounds. The main thing is that you can actually add a camera system into there, and if you actually draw a spline with the Z-Space pen around the simulation, around the 3D model, you can drop the camera on it and the camera will run along this spline path, which is really good for lean design because you can actually draw out worker travel paths. And again, this is a form of reducing upon motion, which is obviously lean waste. So it's actually quite a cool little function. You can obviously assemble, you can add physics. So if you want to put, if you want to have it animated at some point, you can have physics and you can have crisp packets move around the cell. So this was the proposed system architecture at the beginning of the project, because initially the entire simulation was going to be running through Z-Space, but it was soon discovered that Z-Space isn't actually great for first-person view, because the stereoscopic view with the glasses means you only have a very small head adjustment movement of head, so it makes it quite difficult. Whereas the Oculus Rift, you've almost got that 360 head tracking, which is obviously works a lot better for that immersive first-person experience. Yes, the future features. This is something that was talked about in my thesis. Having a fully simulated manufacturing plant, so not just the new machinery, the proposed machinery, but the entire plant, and having that fully rendered to photorealistic quality. Cooperative multiplayer, so you and a team of operators during that learning process can go around this plant and you can work as a team to address problems. And then you can also have a managerial oversight, so the managerial staff can observe the players running around the plant and accessing and then implementing certain problems, maybe like a machine breakdown or a jamming or a bottleneck in certain stations, and you can basically gauge how well they address the problem and where further training is needed. So it's breaking down the problems that can arise in the workplace and then simulating that for them. Again, it gives you the insight into a numerical standard almost of how well they can address these problems and where further training is needed. And obviously you can also have the artificial intelligence workforce. So again, it's adding that level of immersion, narrative immersion, where you add artificially intelligent workforce, they can all have their own jobs and go on the plant, and you can see that rather than you and a couple of other players in a desolate workspace. It doesn't break that immersion. So if the user can understand how to beat the simulation succeeded in teaching the user how to fulfill their role in the plant. And this ties into game design, or just playing games in general. If the game has taught you how to beat it, then you have successfully learned how to play the game. And if you can transfer that sort of teaching methodology towards simulation and learning packages, then obviously you will eventually train a workforce in how to fulfill their role to a certain standard. So it gives the operators a deeper understanding of their new work cell, potentially involved and they're also potentially involved in the design process through feedback and user testing. And again, this reduces resistance to technological implementation, which is nearly half of a company's workforce as recorded today. So again, reducing that sort of resistance to new technological implementation through getting the workforce involved in the design process, getting that feedback and having the software, especially the design software, which isn't actually that hard to use. They can actually have some sort of basic design control over the cell. So the people who use it every day for 12 hours have that sort of input, and rather than just being forced on them at the last minute and deciding how to learn it, they're actually involved in the process and they actually want to learn it. And that's what the immersion element about it is. While immersion isn't actually tied with cognitive load, it actually makes the user want to come back and learn it, and that eventually allows for effective knowledge production. So you can replace, ultimately the aim of this is to replace online training programs with immersive virtual reality. Because online training programs are more like question-based objectives and things like that, and it's not really that engaging for them. So again, they're not really taking it on as much, and again, it distorts their view on what lean methodology is and how they're supposed to address problems. Layout design, the designer obtains a more realistic understanding of the form of the cell rather than just seeing it on a desktop monitor. They actually see the 3D object there in front of them. They can see it in perspective, which is interesting because you can actually throw it around, you can manipulate the shapes, and you can arrange forms, you can draw out a travel path, which allows you to gain a deeper understanding of what the cell is going to be. These cells are very expensive, so this sort of technology and reducing that sort of risk when it comes to implementing this equipment is needed. Thank you for your time. Any questions?
Coming in. Okay, so we do have time for some questions. Yeah.
Are you intending to take this forward?
Well, now my MSc's over it, probably not, but I'd really like to. I'm on a research position at the moment, which I'll be using C# again, but I see this is really to open the floodgates to show potential. I'm actually showcasing the Rift simulation on Tuesday for Pepsi, some of the higher ups in Europe. We've got a big expo for PepsiCo. So that'd be quite cool. We get to show like sort of, I don't know, it's to open the floodgates and make them see the potential of this sort of technology, because it was only a 3-month project, you see. But again, just opening the floodgates, just allowing them to see the potential there as a training package.
Because I know that lean methodology is very expensive to teach, and usually only for the very senior levels of management. So it's quite a good way of filtering it down.
Exactly. It's normally top down, and then you have trainings. Training, it's like a Kaizen event, it's called, and it's Japanese like progressive learning, and that allows the higher ups basically channel the training packages down to lower workforces, but it's only like a 2-day program, so we're, again, it's going to emphasise that distortion of what they actually know. And lean was really a conduit just for this project, but it could have been applied for anything really in the workplace. so you do Six Sigma, agile manufacturing, anything like that.
Yeah.
Did you have any experience of how acceptable this approach is to the workforce in actuality? Or is
How accessible?
acceptable and engaging for
Well,
because they're not necessarily traditional games?
no, they're not. I call it games because that's just where I've come from, you see. But it was good because they wanted to learn it. It was new for them. It wasn't just a basic online training course for them. The people that I was working with in PepsiCo were very excited to use it. They wanted to basically get the workforce to a new level, to a standardised level of knowledge. And online training courses weren't doing that, especially for my primary research. It showed that it was all very distorted. Different level of employees had different perceptions of what the primary wastes were, for example. The basic operators would tell you that the worst part about their job was motion, the amount of walking they had to do between themselves. Some of them would walk up to 10 miles a day, just based on trying to find new tools, replace parts. And then the managerial staff would tell me that the main problem is defects, because that's what they see. There's more errors that way, so that's what they see. The operators don't actually see that, so it's their involvement in getting the workforce to a level where they get some understanding is very important. I think virtuality has the capability to do that.
Yes.
How much time can people constantly spend doing training?
And the Rift, I don't know, because it differs, because if they say 1/3 of people get motion sickness, but that's very dependent on the frame rate. If you can get above 75 frames per second, the response time on the head tracking is alright, but if it's below that, you kind of get a bit of a sluggishness and you get a bit sickly for some people. But again, it's very dependent on the hardware and the person, but I can sit on it for like 8 hours quite easily.
So is there a certain sort of expected time that people spend within their training?
Well, for this simulation, it's normally like 10 to 15 minutes. We can go around it, because it was a very basic form. It's more like a demo at this point. They can go around it, they can look at the new machinery, they can and see all the nice things in there. They can access the machine user interface that's actually in there. That's normally about 10-15 minutes, and then they can pass it over. It's designed for an expert, this project is, so you don't want one person sitting on it for 2 hours because no one else will get to see it.
Was there any sort of educational element in it that gave people some kind of instruction on what to do with the information that they got, so if they spotted some ways?
Well, actually, I was getting to that point. For part of the expo, I've put in potential lead waste, like tools lying around and things like that, and I'm going to ask them at the end of it, the managerial staff that are using it, and the higher ups. Did you notice these lean waste? Did you know what lean waste did you notice? And I was kind of waiting for testing that. While the thesis is over and the project is over, I still like to know that. So that is in there. Piece of machinery lying around.
Okay, thank you very much. Time up, so let's thank you.